It's River to River from IPR News. I'm Ben Kiefer. For decades, the United States has known it has a problem. The rare earth elements that power our modern technology, the magnets in our phones, electric cars, wind turbines, also weapon systems, these rare earth elements come overwhelmingly from China. We mine very little of them here, and we process almost none. And every time geopolitical tensions rise, that dependence becomes a vulnerability. So today on River to River, we're going to talk about a group of Iowans who are working on a solution, not by digging new mines, but by recovering what we've already used and discarded. Let's start with Eric Smith, director and producer of a new film called Urban Mining. He's also vice president of marketing and communication at the Ames Regional Economic Alliance in our Ames studio. Eric, welcome to the program.
Ben, thanks for having us on.
Well, in just a moment, we'll welcome a scientist from the Ames lab there, too, that's sharing the studio with you. But let's start with you because Urban Mining screens on Saturday, June 27th at the Des Moines Public Central Library, part of a film festival there. You are a storyteller by trade, but your day job is economic development, not documentary filmmaking, I understand. How did you end up making a film about rare earth recycling?
Yeah, so through my position, and you had mentioned it, with the Ames Regional Economic Alliance, one of the key aspects of my job is storytelling. And a lot of times, we publish a quarterly magazine. I host a podcast as well. And so we're constantly looking for unique stories to help amplify what's happening across the 4 counties that we work in. And so this story came across my desk. I had met Dan, who I know will be on the episode later, and in Boone, Critical Materials Recycling. And we had connected actually in Washington, D.C., and I just started asking questions. That's the first aspect of storytelling, is just start asking questions. And what they were doing was really incredible as far as taking discarded electronics and recycling them and then pulling the rare earths out of them. At the time, I didn't know a lot about this topic, but, as storytelling goes, you just keep digging, and it's really an incredible story.
Right, and we will be hearing from Dan Bina. I recorded an interview with him at the end of this program, president and CEO of Critical Materials Recycling in Boone. But before we did that, so you're making a film for a general audience, and I've watched it. It's fascinating, about something as technical as rare earth elements. What for you was the real storytelling challenge here? You want to make people care, but you want to help them understand this unique process.
Well, I'll tell you, so when it comes to documentary filmmaking, and I've done a handful prior to this, and so when a story lends itself to it, it has to have some depth. And so as I was talking with Dan, and then he later connected me with Ames National Laboratory, this is a huge national conversation, and yet here in central Iowa, we're looking for a solution for that. And Akenna at Ames National Laboratory, he'll be able to talk about his work related to that. But for me as the storyteller, it's a national conversation, but there are some local ties and work that is happening here in central Iowa. And so really the next thing is, as Dan and I were talking, I tried to assess, well, what access do I have? And so we need to be able to tell the story visually as well. And Dan opened the door. He says, I'll show you everything. I'll show you what we're doing. Again, he connected me with Ames National Laboratory, who was absolutely wonderful and did the exact same thing. They want to help tell this story as well. And I feel very fortunate that we were able to tell part of that through this project, Urban Mining.
Yeah. Walk us through the film. What does the audience see and hear, and who do we meet in this film that are so integral to urban mining?
Yeah, so if you go check out the trailer, which is available on YouTube, that's actually the opening 2 minutes. And what it does is that it sets the scene for this conversation. We have snippets of news articles, from like the New York Times, and you prefaced a lot of it in your opening about how integrated these rare earths are to everything that we do. I mean, the hard drives, wind turbines, national defense, and again, you really teed it up. A lot of this comes from China. And so we are reliant then on a foreign entity who can, very simply, if they choose to, flip on and off the switch. And so the solution is taking place here. What they're doing at CMR in Boone is they're taking hard drives, 1 million just last year alone, and they're recycling them. And within those hard drives, there's a lot of components, there's metals, but they separate the hard drives from that. And that technology and that process was developed at Ames National Laboratory. Mm-hmm. And so a couple other aspects, I'm talking with Dan, I'm talking with Ikenna from Ames National Laboratory on the documentary, but I also get statewide perspective from Director Debbie Durham of the Iowa Economic Development Authority, who's very supportive of pursuing this from a statewide perspective. So again, we don't have a lot of those mines here in Iowa. We don't process a lot of it, but we do have a lot of rare earths here in the United States. So while they're here, what can we do to keep them here and reuse them? And that's where urban mining comes from, the phrase.
You mentioned Ikenna a couple of times. Ikenna Lebedim is a deputy director in the Division of Critical Materials at the Ames National Laboratory, sharing the studio with you. Ikenna, welcome to our program.
Thank you for having me here.
When a filmmaker shows up and says he wants to make a documentary about your work, what was your reaction?
Well, it was more important to tell the story. Most of the work that Ames National Laboratory does is supported by the taxpayers' money, and whatsoever be the mechanism to convey the information of the output of that investment is something that we look forward to. So that was exciting.
Mm-hmm. And back to you, Eric. You've already shown this film to federal officials in Washington. What has been the reaction there? How is this story landing at a policy level as you had hoped?
Yeah, well, I mean, policy is long gestating, I think, as many of us know. But I mean, I think this documentary can be used to help amplify the story overall, in that there are solutions here domestically. And those solutions will require continued investment, but it's important to continue to push that forward. So I know that our team at the Alliance, we've shared it to our federal delegation, and really it's here to help amplify, yes, there are solutions. And for us, of course, we're biased because we want to promote what's happening in Iowa and central Iowa, and certainly in our region as well. But those solutions, although they may not seem natural, like a natural fit, for the middle of Iowa, well, we're here to tell you that they are, and that it can take place, and we can be part of that solution for the entire United States.
Ikenna, before we get into trying to understand the process that was developed at the Ames National Laboratory to retrieve these rare earth elements. The Ames National Lab is, Iowans know it exists, but maybe don't know what happens there. Put it in context. What is the Critical Materials Innovation Hub that you lead there, and how did it come to be?
The Critical Materials Innovation Hub is a U.S. Department of Energy innovation hub that is led by Ames National Lab. If you understand the national laboratory systems for the U.S. DOE, there are 17 of them. Ames National Lab is one of them, located here in Ames, Iowa, sitting on Iowa State University campus. Ames leads the Critical Materials Innovation Hub, established in 2013. And the mission of the hub is to develop technologies and enhance the innovation pipelines for U.S. critical material supply chains. We do this in 3 ways: accelerating research, educating a skilled workforce, and creating de-risk technologies in partnership with American industry. So in so speaking, we have about 22 industry partners in the Critical Materials Innovation Hub, 9 DOE national laboratories, and 17 leading universities.
Mm-hmm. What changed, Ikenna, that made recycling of these rare earths, these materials, so urgent?
Well, recycling is being a very critical aspect of the work that the CMI Hub did from the inception. And I am very pleased with the foresight that the Department of Energy had at the time to begin to look at recycling as one of the solutions to the entire story. There are other aspects of the solution. One is developing substitutes, or what you might call alternatives, and the other aspect is enhancing and diversifying supply. But recycling enables unlocking secondary products. And this is very important because most of those products are already with us here in the nation. So we have materials that were imported in motors and devices and so on. They can go to the landfills and pollute the landfills, or we could recover them and reintegrate them into the supply chain and provide something that could help solve the problem that we have in terms of materials that support our economic and security.
Mm-hmm. Before we go to break here and talk further, I want to share a clip from the documentary Urban Mining. It included footage of Senator Joni Ernst touring the facilities of critical materials recycling in Boone, voicing her support for their work. Last week, Ernst announced that she secured a critical minerals recycling provision in the fiscal year 2027 National Defense Authorization Act. Let's listen to her remarks during a press call.
I secured a provision establishing a Pentagon pilot program to recycle critical minerals from retired hard drives and other electronic equipment. This common sense initiative will help recover valuable materials, reduce our dependence on foreign adversaries like China, strengthen America's critical mineral supply chains, and keep the United States at the forefront of the technologies that power our economy and national defense.
U.S. Senator Joni Ernst will be back after a short break to talk about the recycling of critical materials. Our guests, Ikenna Lebedeem, Deputy Director in the Division of Critical Materials at the Ames National Laboratory, and Eric Schmidt, a filmmaker. It's River to River from IPR News. Back with more River to River from IPR News. I'm Ben Kiefer, talking about critical materials recycling that's happening right here in Iowa, connected with the Ames National Laboratory. If you have a question, we'd like to join our conversation, 1-866-780-9100. River to River at iowapublicradio.org. Later, a conversation I had with Dan Bina. He's president and CEO of Critical Materials Recycling in Boone, to talk about really how it happens on the ground, how it's happening here in Iowa. Right now, we have joining us live Ikenna Lebedeem, Deputy Director in the Division of Critical Materials at the Ames National Laboratory in our Ames studio, joined by filmmaker Eric Schmidt. We played that cut from U.S. Senator Ernst there right before the break. Ikenna, talking about securing a critical minerals recycling provision in the fiscal year 2027 National Defense Authorization Act. What is the significance of that move by the government?
I think that's very significant in that it would help support the recovery of these critical materials, especially from hard drives. Hard disk drives are one of the easiest and I think one of the simplest things we could do because they are concentrated. Unlike cell phones and other electronic devices that are dispersed everywhere in our society, the communities, in our drawers and here and there, hard drives tend to concentrate in data centers. And so having the ability to process these materials, efficiently recovering the rare earth elements and other critical materials that are contained in the hard drive and then reinserting them into the supply chain, I think that's a win-win for everybody.
Yeah, right. And I understand that rare earths are something like 2% of a hard drive. So it's rarely worth it economically to try to recycle that. But you in your team invented the acid-free dissolution recycling process, known as ADR, back in 2015. Can you explain in simple terms that we could understand what was wrong with the old approach that made it not economically viable, and what your process does differently?
Yeah, so the process to recover rare earth from electronic devices is complicated. Often people tend to say, oh, I recycle rare earth elements from my hard drive. And you hear things like, well, we recycle magnets. The fact is that often what reaches the end of life isn't the magnet that is in the device, it's actually the device itself. So the question is really, how do we efficiently recover the magnet and recover the rare earth that is contained in the magnet? The traditional approach to doing this used to be the fact that the materials would be initially demagnetized, and then you will pre-concentrate the magnet content of the hard drives, then followed by trying to oxidize the magnets. And that oxidizing the magnet is very important in those traditional steps, because you would then take these magnets and then put them in acid. If you put them in acid without oxidizing them, that is heating them until they are no longer metals, that's likely going to cause some hydrogen evolution, which might be okay in small quantities, but if you're working in tonnage, that becomes a big problem. And all those pre-processing steps, they add to the process. What our process does is that it selectively recovers rare earth from shredded electronic waste without deteriorating the other components of the electronic waste. So gold is still recovered as gold, aluminum is still recovered as aluminum, and the rare earth goes into the solution to be recovered. All these are done without the use of mineral acid in the dissolution.
It's really quite remarkable, because I guess when I thought of, maybe hard drives, if you would have said, okay, how do you recycle a hard drive? I would picture lots of people trying to take it apart and then, dissecting it more or less. But here, as you can see in that film trailer that Eric made there, Urban Mining, it's really taking an entire hard drive and putting it into something that looks to me like a meat grinder, a sausage maker, grinding it up completely, and then putting it through this chemical process, Ikenna.
Yeah, the grinding is actually a necessary part of decommissioning end-of-life hard drives. The grinding is normally not done for the intent to recycle, but to destroy the data that are contained in the hard drives. So normally when they reach end of life, typically data centers would subject that to shredding process, and then it will be shredded into pieces. That is what our process uses as the feedstock. And so once it's ground, we then begin to selectively pour the rare earth into the solution using our process.
Mm-hmm. Ikenna, you're a researcher at the National Lab, have been, I think, about 15 years at the Ames National Laboratory, a nonprofit supported by taxpayer money, as you noted there. There's sometimes a gap between what gets invented in a lab and what actually makes it to market. So this must be pretty significant to see this technology that your team invented operating full time in Boone.
It is exciting. And I actually would credit that a lot to the foresight of the Department of Energy in establishing the Critical Materials Innovation Hub, and the leadership of Ames National Lab in ensuring not just that the environment that enables the technology development was created, but also create a platform to advancing the technology. I was discussing with someone recently, and I did remark that the role that the state of Iowa played in this technology development is very critical. There was a time we needed our own shredder in order to evaluate the efficiency of the technology, and we didn't have one. And we got one from a funding from the state, and that allowed us to move forward. So it is very exciting, and I'm very grateful for the opportunity.
Mm-hmm. How did the connection with Dan Bina come about, Ikenna, and what made his company, the Critical Materials Recycling, CMR, the right partner to commercialize this technological breakthrough?
Yeah, that's a very interesting question. You know, the interaction with critical materials recycling began with a company that Dan leads, which is called TD Vibe. TD Vibe is a company that produces rare earth device that is not permanent magnet, but that's used in sonar transducers and other types of applications. And so they've been working on rare earth related materials before, but not in terms of the recycling. And I recall visiting them at a point, and I saw a lot of rare earths that is sitting in the bucket, and asking the question, hey, what are you guys doing with this? And that's where the discussion began, and we started introducing the technology, and they chose to license it out from Iowa State University Research Foundation, and we've worked in partnership since then.
Mm-hmm. And as noted in my introduction, this is an active conversation, an urgent conversation about reducing reliance on China for critical minerals, since in so much of our technology. Put what is happening here in Iowa in that context. Is this a small piece of the puzzle, a significant piece of the puzzle, a piece of the puzzle that could grow into something significant? How would you characterize it, Ikenna?
So, I think this is a significant piece of the puzzle. Obviously, recycling alone is insufficient to address all our rare earth problem. That's known. Nevertheless, it could be a significant aspect of the solution. I want to give you one example. There is a rare earth element that we call dysprosium. This rare earth element is one of the things that make magnets very powerful for different high performance applications, including defense, and the use in, say, electric vehicles and so on. The mine we have in the United States has very, very little amount of this dysprosium. But the good news is that this dysprosium is already contained in devices that we imported in this country. And it is very easy for us to leverage technologies like acid-free dissolution to begin to establish a pathway to helping supply dysprosium, in addition to other rare earths that are using magnet to the commercial sector. So this is significant, and I believe that a significant amount of our rare earth supply could come from recycling in about a decade or more to come.
And I understand. And so up to now, up to recent times, I should say, our hard drives, there are a lot of hard drives with these rare earth elements in landfills across the country, aren't there? Unfortunately.
Unfortunately, some of these materials, especially the ones that are used by the general public, don't make their ways to being recycled. But that also represents some opportunity. We're working with a company that is in Indiana, and what we've done is to ask the question. Often it's not very easy for the hard drive to travel all around the nation to come to a single location. And so what we've done is to modularize the acid-free dissolution infrastructure and place it near the place where the waste is generated in Indiana. The general public turns in their devices in there, and they just put it through the acid-free dissolution system, recover the rare earth, and still continue in the work that they are doing. So this is really technology developed in Iowa, beginning to make its way around the nation.
Mm-hmm. I understand that one of the challenges here, Ikenna, is trying to anticipate which materials, which of these rare earths will become critical before there's a crisis, a shortage of it. There are a lot of different rare earths. Help us understand their how many there are and what materials you're watching most closely right now.
Well, there are different rare earths, but there are a few of them that are really mostly used in terms of permanent magnets. Most of the rare earth in terms of market are dominated by the permanent magnet market. One great thing with the Critical Materials Innovation Hub, as well as the Department of Energy, so the DOE does what is called critical materials assessment. And so this is usually a forward-looking assessment, and the goal is to understand materials that would be categorized as critical or near critical, and those that aren't, especially those that are used in energy-related applications. And the USGS also does their own analysis. So it is not only rare earths that are critical, there are a lot of other materials that are also deemed critical. In the Critical Materials Innovation Hub, we do what is called our own criticality assessment. And this allows us to look at the materials that we could advance in terms of the funding level that we have from the Department of Energy, and then we explore those materials.
Mm-hmm. Ikenna, we are speaking midway through 2026. Where does this go from here, both in terms of research and the commercial application of this recovery, this recycling process of rare earths?
Yeah, in looking into the future, the technologies like the acid-free dissolution recycling is really prepared to be widely deployed. In terms of critical materials, there are other challenges because recovery of the materials is one step. Refining the materials and making them into application is a different set of challenge. And the Critical Materials Innovation Hub is addressing that. The approach we typically use in our operation is to create technology with the goal of captivating industry and ultimately catalyze deployment. And we've done this significantly in different areas. We've created 27 technologies that are licensed today, and we have almost 67 patents, 700 publications. And the way we look at the impact of these is that the technologies we've created have gone to attract both private and public follow-on investments of almost $140 million. So there is a great opportunity coming in terms of being able not only to recycle, but to refine these materials going across the supply stages.
We have a minute or two left. Ikenna, we know Iowa is a state that runs substantially on wind energy. We're one of the nation's leaders in wind energy. Does that give this work a particular resonance here? Because the idea that turbines generating our power could eventually feed back into their own supply chain. You've talked a lot about hard drives, but these old wind turbines, when they've, done their service, that is a good source of raw material for recycling as well?
It could be, and I use the term "it could be" because most of the wind turbines that are used inland are often the ones that run out of induction, meaning that they do not run out of a permanent magnet generator. Some could. But I also want to mention that there are other magnets that are contained in wind generators. So it's not necessarily in the drive itself. In different electronics and components, you have magnets here and there. So yes, it could contribute. But a significant amount is going to come from the magnets that are used in offshore applications.
Mm-hmm. Eric Schmidt, we have less than a minute, but your film, Urban Mining, is so interesting and promises for the future. The last word to you about perhaps mentioning where people can find out more about urban mining, the ideas in your film.
Yeah, great plug. So the Des Moines Art Festival is taking place this upcoming weekend, and adjacent to that is the Interrobang Film Festival. So they run in conjunction, and the film will be playing on Saturday, June 27 at 4 o'clock, and all of the information is available on the Des Moines Art Festival website.
Okay. Thank you very much for stepping into our studio. Eric Smith, filmmaker, Ikenna Lebedim, director in the Division of Critical Materials at the Ames National Laboratory. And this is an exciting field. I can only imagine a generation of students at Iowa State and elsewhere going to spend their careers on problems like this one and further innovations. Thank you very much, Ikenna and Eric.
Thank you for having us.
We'll be back with Dan Bina in just a moment. It's River to River from IPR News. Back with more River to River from IPR News. I'm Ben Kiefer, talking this hour about the science of recovering rare earth elements from, discarded electronics, wind turbines, hard drives. So let's hear from someone who has turned that science into a business. Dan Bina is president and CEO of Critical Materials Recycling in Boone. That's a company founded in 2021, and it grew directly out of the research that we've been discussing this hour. I spoke with Dan last week. Welcome to our program.
Thanks, Ben, for having me. I appreciate it.
So, Dan, you have a background in mechanical engineering, but within that field, you were drawn to something called smart materials. And remind us where that term has its origins, because that comes from decades ago at the Ames Lab, doesn't it?
Yeah, that's right. Although my background's mechanical engineering, I wouldn't say I was drawn. I was more so life threw me in that direction. One of the jobs here been over a decade now, landed in this position where these smart materials were being produced, designed into different products and applications. And that's what led us into this rare earth recycling. But as far as smart materials, these materials really are a unique technology that you can manipulate the length of these metallic materials and have very tight control over them. And they're used for very niche applications, originally for the Navy and their sonar products. But they call them smart because they are a very unique type of material that you can control in unusual ways.
Tell us how your work eventually connected you to Ikenna and the research happening at the Ames National Laboratory. How did that relationship begin?
So the technology that Ikenna had developed was specific to recycling rare earths. And these smart materials that we produced are rare earth based. Along with the fact that we were actually located at the Iowa State University Research Park, which was right there in Ames, where Ikenna was at. They reached out to us very early on in that development because they understood the materials we were producing and saw a potential use case for us internally to recycle our smart materials or the rare earths. So that's really where it started and it came from. We had the introduction again very early on. We recognized, however, that the use of this technology to recycle rare earths had a much larger application in the permanent magnet world. So we expressed that interest again early on, and we've been working with them ever since.
And it's really remarkable when we hear the story of how we got into this position with having China be so dominant in this area. When were you first aware of that and then said, hey, there is a business opportunity there and a chance for the United States to catch up in this alternative way, not mining, but recycling?
Yeah, so the scenario where China is kind of dominated has been around for many decades. As that technology was introduced to us, the main reason they had started developing it was because they realized that that was something that the nation needed to address overall for industry in general. So that's kind of when they started it, when that pressure and some of the geopolitical issues that were occurring at the time really pushed them in the direction of developing something for the United States to be able to implement and really take those geopolitical risks and address them directly. So that was probably 2017 or so that this really all started. And then we realized the value right away, like I mentioned before, how this applies to really rare earths in general, But if you look at all the rare earths, there's about 16 or so on the periodic table. It's really 3 to 4 of them that hold about 80% of all the value within the rare earth industry. And those three are all directly tied to permanent magnets. So that's where we really saw the potential for us to be able to use this technology, not only internally for our smart materials, but also to address this issue with permanent magnets.
Dan, you are president and CEO of Critical Materials Recycling. You're located in Boone, and you've been operating full time now. You can see it in this documentary film, Urban Mining, but help us form sort of pictures in our minds for those of us who haven't been able to see that documentary film. Walk us through what a typical day actually looks like on the floor of your business in Boone. What comes in the door and what happens to it?
Yeah. So this material you had mentioned earlier can be from a range of different sources. And you included some of the main materials that we focus on, which would be hard drive materials. So think of end-of-life hard drives from data centers. So there's millions of those every year. But other things such as wind turbines, and here in Iowa, we're number 2 in the country. So we do have a lot of those wind turbines that come down every year. But then other things like EVs, you can also think of household stuff, like a lot of your cordless power tools, all of your e-mobility devices, like your scooters and so on. But we get those materials at end of life. So we do work with a partner, a traditional scrap recycler, and they will get those materials when you or I or industry is done with them and ships them off. They do some pre-processing. So as you may imagine, for a wind turbine, they don't truck one of those in, the whole thing in our door. They really tear those down, separate out for all the different materials. And for us, the magnet or the steel component that has the magnet in it would come to us. For hard drives, it's the same thing. Those hard drives are typically shredded up for data security. Those can be further processed so that really the steel, which will contain all the magnet fraction, is separated out. That comes to our facility. And then once that comes in the door, it will start to go through what's called the acid-free dissolution recycling technology, or ADR. And really that process is fairly simple. So if you imagine that shredded up steel with the magnet content in there, we would take that material and put it into this copper salt solution. And again, it's acid-free, so that copper salt it's not acidic, it's a neutral, at neutral pH. And that material sits in that solution, and it selectively will pull out the rare earths from in that magnet. And now those rare earths are in solution, kind of like dissolving sugar in water. At that point, we can take all the solids, which is basically everything you saw going in. We can just separate those out, drain the fluid off. And then there's a precipitation step, which we cause the rare earths to fall out of solution as a solid. And then we can take those solids and it goes through a wash step. Now, those materials are already pretty pure when we precipitate them, but we're going for 99.5 or greater purity, which is pretty high purity. That's what's on the open market. That's what's expected. So we go through a wash and get to that higher purity. And now we have a high purity rare earth oxide ready to go out the door.
We could think about hard drives, for instance, turbines as well, going back many years now. So there's quite a backlog of waste that can be recycled here. And to think here, in previous times, before this recycling, Dan, things were, tossed into a landfill? There's a lot of these rare earths put into landfills while we're really needing that in our current technologies?
Well, yes, but no. I don't want to give the impression that these materials were just completely thrown in landfill. Most all these materials have been and are recycled, except for the rare earth content. And it's not like they're trying to single it out. It's just that there really hasn't been the industry here in the US. And in the case of things like hard drives where the magnets are mixed in with everything, there hasn't been a technology that's been capable of recovering them. So for the most part, most of the materials are recycled. So think of steel, copper, the precious metals, those kinds of things. Those are recycled. But the rare earths have been harder to get to, and there hasn't really been an industry to get them. That's what we're now introducing with this technology, the capability to go after them and recover them.
So if I'm understanding you correctly, the breakthrough was really this ADR technology that you described.
Correct. Yes, that allows us to recover rare earths from materials that the traditional process isn't capable of getting.
When you're talking with potential customers or investors, how do you frame what your company, CMR, is doing in terms of the larger supply chain picture? Give us your company, how you're creating or fitting into a niche that is hopefully expanding.
Yeah. So really, from a very high level, you had mentioned how China dominated this market, and they still do. Um, Here in the U.S., there are not a lot of companies that produce rare earths, either from a mining standpoint or from a recycling standpoint. Much of that industry is developing now, but if you look about 10 years ago, it really didn't exist at all here in the U.S. So what we're really doing here is developing that entire ecosystem so that we're able to recover those materials from all these end of life materials that we're discarding that have rare earths in them. So that's the most immediate and near term solution for us as a country to really get these materials in large numbers. Now, down the road, I mean, obviously, you will need mining to provide a large percentage of that material. But for something right now, today, or tomorrow, recycling is the way to go.
Yeah. And is that forever to be a small fraction or a fraction? I don't know if you can give us a number of what the recyclate will turn out to be in the bigger picture of our needs for these rare earth minerals.
No, I think the best example is if we look at some of the other materials recycling that we do here and have done for many years. Aluminum is a good example. Right now, I believe the numbers is somewhere around 70% of all the aluminum that goes into production that to make products. 70% of that comes from recycled content, and obviously that takes many years to develop our society, the industry, to recognize that we need to be recycling and then have technologies and capabilities to recycle and then put back into product. Rare earths in general are quite a bit more expensive than aluminum. And for that purpose, as we move forward, we're definitely going to want to be capturing those rare earths in as high of a percentage as we can. And it may be comparable to aluminum in the future, but I would anticipate that rare earth recovery and reuse will be a significant portion of what we're producing every year.
And for you at Critical Materials Recycling in Boone, where do you want to be in 5 years? What does success look like compared to where you are now?
Well, that's a good question. So we do have our plans and our goals, and some of those you call like a moonshot. What are we really looking for here? In our industry, if we look at how much rare earth comes into the U.S. In products and raw materials, you're looking at the tens of thousands of tons of material a year of rare earth material. So our nearer term, as we're operating on a day-to-day basis here as pilot, we're around that 20 moving into 50 tons. So that's a small number. But looking in the next couple years, that's going up to about 300 to 400 tons a year. And then again, another few years, we're talking several thousand tons. So it is a step by step, but we're working towards being a significant supply source here in the U.S. Moving forward.
Iowa, the site of the Ames National Laboratory, we're world famous, of course, and Critical Materials Innovation Hub, your company there in Boone. A real cluster of this work happening in Iowa. Dan, is that a coincidence or something specific about Iowa's research and industrial ecosystem that makes it possible here?
No, you said it right there. It's not a coincidence at all. The Critical Materials Institute there, they are recognized nationally and globally as the top institute for rare earth and other critical materials research and development. Again, that's where the technology came from. The original inventors, talking to Kenna, his partner Dennis, they searched for a partner to further develop and commercialize this material, understanding that it's important to have that close working relationship to develop and scale this out. And that's one of the reasons they've told us that they chose to work with us, as we are close and able to work together, and we have for the last 9 years. So that has been instrumental in the progress of this technology and where we are today. So yes, I would say that's not a coincidence at all.
You're still a relatively young company in the field, didn't exist a few years ago. What's been the hardest thing to figure out, Dan, in this development? The technology, the business model, finding customers, or something else entirely? What would you say was the hardest challenge so far?
Right. Well, give a little context there. We're not exactly formed in 2021 for what we're doing. This work originally started in 2016 with our Smart Materials and our sister company, where a lot of the original development really was done for ADR. And again, CMR was actually established in 2021 to kind of spin it off and be able to focus on the recycling itself. But looking at what those challenges are, the biggest challenge for us has really been the fact that rare earths does not exist, that ecosystem does not exist in the US. When we look at, the standard approach to building a company out and reaching customers and developing technologies, a lot of times you get advice that works for industries that are already there, that you're trying to break into and expand. It changes a lot when those industries don't exist in the first place. So our biggest challenge has been to not only develop this technology, which is the recycling of the rare earths, so we have a rare earth oxide, but there's multiple different partners downstream that need to do further processing to end up into a final product. And those companies did not exist as well. So our biggest challenge has been to work with these other companies and develop the entire ecosystem, not just the recycling piece that our technology focuses on.
Dan, before we say goodbye, we have just a few seconds left. Is there something you wish policymakers in Washington understood about your emerging industry that they currently don't?
Well, that's a good question. To be honest, there's been a lot of conversations with the government in different forums. I don't know that I have one that sticks out at the top of my head because we've been discussing a lot of them. I guess what I could say is they're very aware of the situation, and they are looking at multiple different options and angles to attack this and help develop out this ecosystem, not just the recycling, but all the other parts of this ecosystem. So I don't know that I have something specific to direct them to, but they're definitely working on it.
Dan Bina, thank you. President and CEO of Critical Materials Recycling in Boone. Enlightening, interesting, and has a real future here. We're seeing that. Dan Bina, thank you.
Yeah, thank you for having me on.
Today's show was produced by Samantha McIntosh, with technical support from Nev Kelly and Jason Burns. I'm Ben Kiefer. Thanks for joining us.